Now we're going to look at what happens when we add 10 milliliters of a 0.1 molar NaOH solution to our initial HCl solution. So once again, because it is a strong acid, we can say that HCl is equal to the concentration of hydronium, which is 0.1. And actually we can say the same thing about NaOH. So for every 1 mole of NaOH, we get 1 mole of hydroxide. So we can say that the concentration of hydroxide is also 0.1. Because we're going to be doing a neutralization, that is a type of reaction. And so the first thing we need to do is look at how many moles of hydronium and how many moles of hydroxide we are adding to this titration. So remember, moles is equal to molarity times volume. So when we do this multiplication, we get the number of moles of hydronium that we are starting with, and then the number of moles of hydroxide that we have added during this titration. The next thing you want to do is see where we are at in this titration curve. Here, the number of moles of hydroxide is less than the number of moles of hydronium, so we know that we are still before the equivalence point. We also know that hydronium and hydroxide neutralize each other, and that this happens in a 1-to-1 mole ratio. So for every 1 mole of hydroxide that we add to this titration, we use up 1 mole of hydronium. Because we're before the equivalence point, what we want to do is find out how many moles of hydronium remain after we do the reaction with hydroxide. So if we know that we started out with 0.005 moles of hydronium and we've added 0.001 moles of hydroxide, and we know that 0.001 moles of hydronium are being used up by that hydroxide, we find that we have 0.004 moles of hydronium remaining. So for every 1 mole of hydroxide we add, we use up 1 mole of hydronium. We have an initial amount, we use up a certain amount due to the interaction with hydroxide, and then we have a remaining amount of moles of hydronium. So we're not quite finished yet because we need to know the concentration of hydronium. And so you need to remember that we started with 50 milliliters of our HCl solution, and then during the titration we actually added 10 milliliters of NaOH. So at this point in the titration, our total volume in our flask is actually 60 milliliters. This is very important. This is the #1 place that people make mistakes in these kind of titration problems, is they forget to look at the total volume. You got to remember, as we go along this titration, we're going to be adding sodium hydroxide or a certain volume of sodium hydroxide to the titration. So our V total is going to change. So here our V total is 60 milliliters or 0.06 liters. So we take the number of moles of hydronium that we just calculated up here, we divide by the total volume, we get the new concentration of hydronium after we've added 10 milliliters of our sodium hydroxide solution. Once we get this, we plug it into our pH equation, and then we get that the new pH is 1.18. So you can see, even after adding a little bit of sodium hydroxide, our pH has changed very slightly.